displacement and distance by y equal to function of x means equation of path given. Just consider an example. In this example, we have been given a equation y equal to 2 by 3 x minus 1 to the power 3 by 2 is equation of path followed by a particle. We have to find displacement and distance between two positions corresponding to positions with x equal to 1 and x equal to 4 meter as x coordinates. Now just consider this situation and try to find the solution in a general method. We are just drawing xy curve for the given particle. Say this curve is of this shape. Here let us consider this point on the path of the particle. You can say it is a position, initial position, which is given as say A. X coordinate of its position is say x1, and there is another position B. Consider it as the final position in our example. X position for this second position of the particle, x coordinate is say x2. Now if we want to talk about displacement of the particle, then it can be easily calculated, because direct distance between A, the initial position, and B, the final position, is called the displacement. Here we can get this displacement AB by using Pythagoras theorem, because we may easily conclude that this distance, the position x coordinates distance between these two positions, we can write it to be x2 minus x1. We may call it delta x. And here this distance, say this is the point C, so the BC distance is obviously will be represented by the y coordinate of the final position minus y coordinate of the initial position, means y2 minus y1. It can be treated as delta y. Then displacement will become equal to under root of delta x square plus delta y square, and hence the displacement AB can be written here as under root x2 minus x1 square plus y2 minus y1 square. Here in the given example, for x1 equal to 1 meter, we can get y1 equal to 0, and for x equal to 4 meter, we can get y2 to be equal to twice root 3. So by putting these values into the relation AB equal to under root of y2 minus y1 square plus x2 minus x1 square, as x2 is 4 minus x1 is 1 square plus y2 is 2 times root 3 minus y1 is 0, its square, so it becomes under root of 9 plus 12, or it is equal to under root of 21 meters. It is the displacement. Now if we want to get the distance traveled in the same example, then again we have to draw the same curve for the given equation. Here at this side we are taking x and at this side we are taking y, and the curve is say of this type. For the two given positions, position A we are taking here x equal to x1, and at the other position B we are taking x equal to x2. This is the position A, this is the position B, between which we have to find the length of the path traveled, because distance is termed as length of the path traveled. So here we are just taking a small part of this curve between A and B. It should neither be at A and neither be at B. It must be in between A and B, and after taking this, if we draw this curve at the next page, then we can indicate here the distance or the length of the element to be dl. If we talk about the x displacement during this traveled length dl, then we can get the shifting in the x direction and shifting in the y directions are dx and dy. Then we can easily write by using Pythagoras theorem again that dl is equal to under root of dx square plus dy square, or it is equal to under root of 1 plus dy over dx whole square, and outside the root dx. As this is the small distance traveled in a very small part of its path, then if we want to get the complete length of the path, means distance traveled between A to B, then it can be achieved by adding all the small distances starting from A to B, and it can be achieved by integration within the limits x1 to x2. If we integrate this dl, or root of 1 plus dy by dx square with respect to x, then we can get the entire length of the curve from A to B. Now, as here we have been given an equation y equal to 2 by 3 x minus 1 to the power 3 by 2. By differentiating it, we get dy by dx equal to under root of x minus 1. By differentiating this equation, we get this result. So here we can write complete length of the path starting from A to B is integration. X1 is given here 1, x2 is given here to be 4. So under root of 1 plus square of under root x minus 1, it is x minus 1. We are going to integrate it with x. So it now becomes 1 to 4 root x dx. Obviously, the result tells us that the answer is 2 by 3 x to the power 3 by 2 from 1 to 4. So by putting the values of limits, we can get it to be, if we put x equal to 4, then it comes out to be 8. So 16 by 3, 8 into 2 by 3, it becomes 16 by 3, minus when we put x equal to 1, then it becomes 2 upon 3. So the final answer for distance between A and B is 14 upon 3 meter. Here you can conclude that the distance traveled is greater than the displacement, as we achieved earlier. The displacement here was under root of 21 meter. Here under root of 21 meter is less than the 14 by 3 meter. So it again proves that displacement can never be greater than distance, and here by following this method we got distance traveled by the particle and displacement of the particle as well. So using this trick you can get any distance or displacement traveled by a particle if its equation of path or equation of trajectory is given.